Hello everyone, Brett Kelly here for another Tuesday Tech Tip at 45 Drives. And well, this week we're focusing a lot more on the tech tip and less on, well, opinions and stuff. I feel like I've been doing a lot of talking when I've been on here lately. So, this kind of falls into the little subset of our tech tip series that I like to call, I wish this video existed when we learned this process. And what is this process, you say? Well, today we're showing you how you can add a dedicated SSD, or journaling in kind of Ceph terms, to an existing spinning OSD. So we're not migrating a journal, we're adding a new journal to an existing OSD. The official supported way is kill the OSD and rebuild it, but this will save people a lot of time, so we wanted to show it to you. So without further ado, let's get into it. Let's hop onto the terminal I've got beside me, and let's convert some disks. Some OSDs? I don't know. Either way, we're going to have some fun. All right, so here we are at a terminal on my workstation here. So looking at our Ceph-S, so geez, can't speak today. Well, I seem to say that in every video, don't I? Health's okay, relatively small cluster. What are we working with here? We've got 5 disks in each node, and all of them are hard drives that you can see. So I want these to have a journal. So just let's make sure. Let's take a look at Ceph LVM list. This will spit out each OSD, and as you can see, each OSD has a block. But when you build these things with journals, with a dedicated SSD for it, you'll get a little DB device here as well. That's not present because we just built a spinning disk Ceph cluster. So we already knew that. That's why we're here watching this video. We started with a spinning disk. I want to add some SSD to it. So let's take a look at what's in our system here. So if I use LSDev, I've got a Q30, and these are equal in all 3 nodes. So you can see disks 1 through to 5 here are all hard drives. And the rest of my disks in my system are SSDs because I've been using this as an SSD cluster. However, we're going to take device like 1.6 here in slot 1.6, and we're going to partition it up, and we're going to give each partition to one of the hard drives there. Again, we're going to do this process manually. The best way to do it is with an Ansible playbook because it'll just do it disk by disk, but that's no fun to watch in a video, is it? So I'm going to take first this disk 1.1, and I'm going to convert it such that it's split its block DB or its journal in, I always put that in quotes because journal is not quite the correct term, but it's stuck because it's been here forever, but it's going to put the journal or the block DB on a separate SSD and leave all the data on the existing OSD. I don't have much data on it, but I do want to show you. Ceph OSD, Ceph-S will show us. I've got about 20 gigabytes on this thing. Not a lot, but it's just for illustrative purposes. There is objects on this cluster, and if I did do this wrong, Ceph would be mad at me because it would be missing the objects that were on that cluster. Actually, I can go a step further and make this pool a, yeah, you know what? Let's play fast and loose here. I don't know why I said that. That wasn't funny. Ceph OSD pool set. I called it test pool. I'm going to set the size to 1. So what this means is there is no replication at all. I'm writing one object to the cluster, meaning that if I do screw this OSD up, the data will be gone. So, you know, it's kind of, I'm trying to think of an analogy, but nothing's popping in my head. But it's just to show that the data that's on the disk, I'm going to stop it, do some work to it, and put it back in, and the cluster's just going to keep on moving like nothing happened, which is exactly what everyone would want. Anyway, I've rambled enough there. Let's get into the process. So, we were talking about Dev 1.6. This is an SSD, and it's in slot 1-6 on my Q30 Storinator, and I'm going to partition that thing up such that all 5 of those disks can use a piece of it. It's a really big SSD. In my case here, I'm only going to build a 30 gigabyte journal size for it, and I'm just going to work on 1 disk and 1 SSD right now. So let's get started. So the first thing I'd want to do is make a physical volume on the SSD. So I'm going to run pv create. Boom, successfully created. The next thing I'm going to do is run vg, and I'm going to call this db0. Best process would probably be to use the same naming convention as Ceph volume does when it deploys these things. And you would want to use like random UUIDs for that. When you do this with the Ansible playbook method, it will do this. For illustrative purposes, I'm just going to pick really easy human readable names. So I'm going to build a volume group called Ceph db-0 on the SSD. Okay, and then now I'm going to create a logical volume, a piece of that SSD that we're going to give to one of these OSDs. So I want to give it in terms of extents. I'm not going to give it a size. I'm going to say you have this many physical extents. This is all LVM speak for how many chunks. By default, LVM will use an physical extent size of 4 megabytes. So obviously if you want to do 30 gigabytes, gebbies is really, if we're talking power of 2, you would just divide 30 by 4 and take that extent. I've already got a table here with all that there, so I'm just going to drop it in. It's 7,680. I'm also going to give a name to my DB. So again, we would use a UUID in a randomly generated UUID to match the naming convention, but for illustrative purposes, I'm going to keep going with this. And then we're going to, so what we're doing is we're creating a logical volume called that, OSD DB0. On volume group DB0, which is on the SSD that we want to do. It is 7,680 extents big, which is 30 gigabytes. Someone who's built a Ceph cluster might go, I've never really had to deal with that before. When you build these things from scratch, Ceph volume handles all this stuff for you. It's because where we're kind of coming in and doing, not a hack, but just coming in and doing it manually, we have to get a little more involved. Okay, so now that we have a logical volume that we can use as a DB partition or a journal partition, we can continue along with the process. So the next step is to chown that device, so Ceph has full control over it, and we're going to give it the volume group name, and then we're going to give it the, no, it's OSD. We're going to give it the logical group name, so we do that. chown, and we're going to go -r, Ceph, and you have to do the underlying DM device as well, but I hate having to map that out, so the easiest way is to just do Ceph db, just wrap it with real path, so it'll do the resolution, there's the word for you. Resolution. I worry about myself. Okay, so we signed the permissions. That's kind of boring, but that's so that when we actually start this OSD after, it's allowed to use the DB. If we hadn't done that, the OSD would fail to start, even if we added it correctly, because it wouldn't have permissions. Root would still own that device. So now we actually are going to take the OSD down that we want to work with. So Ceph OSD tree, I want to take down OSD1. Before that, I want to make sure that OSD1 is indeed device 1-1, so 1 slot 1. Sorry, in slot 1-1 on our Storinator. So we're going to go find OSD. No, you have to give it the right path, Brett. That's how that works. Find OSD-I, and so I'm looking for OSD ID 1, so I want to find OSD 1. So this script will tell us what host it's on or which device. So we are indeed, block device is dev 1-1, so we can continue there. So what I'm going to do is I'm going to set the no out flag on Ceph, so if we do this quick enough, which we will, it won't bother trying to move the data off it because it won't think that the disk is gone yet. So, and then we're going to stop the OSD. Boom. So now we can actually work on it. So this is a little bit of a safety precaution. I just like to flush the journal because in case there is anything on there or cause corruption. It's one of those things where it's like, I did this process without doing this and nothing bad happened, but like, better safe than sorry, right? So there we flushed our journal, great. And now we actually create the new block device. We are going to use one of the Ceph tools. I cut and copied that in. I didn't mean it to execute right away. Good thing, my names were wrong, so it failed. I'm just going to do this because I don't want to copy it all back out. So you have to run this command, this Ceph BlueStore tool command, and you have to tell it what the block DB size is like this. Not really sure why. Seems to be a syntax thing that only allows that to happen. Pulled my hair out for a little bit trying to figure that one out, but this seems to work no problem. So I'm going to type this command out, and then I'm going to tell you what it's doing, so I don't make typos. bdev new db path, which will be var lib ceph OSD ceph -uno. And our dev dash target is ceph dev. So this is our actual like DB that we made, right? So there, so what we're saying is build a block DB size of 30 gigabytes. That's the Ceph args that I'm doing here. Then we're using the Ceph BlueStore tool to make a new DB, so a new journal block DB, the path on where we want it to get created, and then which device we're targeting. So what this will do is it'll essentially, not essentially, it will create a new BlueStore DB. It will symlink it to this directory here, so Ceph's aware of it. And then one would think we're done, but no, not quite. We have to migrate some other data over. But let's run this. So it infers the blue device and it mounts it. So let's take a look at that directory. Oh, look, I'm yelling at you now with caps. ls-al var lib ceph OSD ceph-1. So if we look here, we now have a block which points to our actual like spinning disk block device. But now we also have a block.db which points to the DM device of device member. Anyway, it's just another name for that logical volume we just made on the SSD. If I do this same thing but look at another OSD on this host, if I do 4, you'll see that there is no block DB here because this is just a regular looking one. Anyway, so we're getting close, but we're not done yet. So the next stage, the next step is to run another Ceph BlueStore tool. What we're going to do is migrate. So we created this new DB. Now, we could go finish this whole process, start the OSD, and it'll start. But you'll immediately get a warning that says, caution, BlueFS spillover detected, which just means that at some point your DB might get so full that it does spill over to a hard drive, and then it warns you about that. Because what you need to do is do a bigger DB. So this warning is true in a way, but it'll be confusing. And actually, this is what happened to me the first time. I was like, well, that seemed to work, but why is there spillover? I thought I put everything on the new one. It didn't actually spill over because it's not full. We just never took the old data off the existing blocks DB that was on the spinning disk itself. So not only do you have to make it, you have to migrate the old data over. And so that's what I'm about to do with this command right here. So same idea, which path is it working on? So we're going to go var lib ceph OSD ceph-1. Then we're going to go devs source. And I'm not going to do that. I'm going to do dev. No, sorry. It's the same path again, Brett. See, this is what happens. I try to explain what I'm doing when I'm writing commands out, and I forget what the commands are. Single track mind. Block. So our source is the original block device. No matter how you build a Ceph OSD, this blocks DB is always present, even if it's just a spinner. So now that we've made a dedicated one, we have to take what's existing on there and put it over there. But I'm repeating myself, so I'll keep going. Dev-target. So our source, we're taking it from the existing block device. And where are we sending it? Anyone in the crowd? No? Yeah, no, I can't hear you anyway. We're sending it to the new block DB, right? Our new mounted point up here. So before I run that command, I'm just make sure I got everything. Yes, I forgot the most important argument of all, to actually tell it what to do. bluefs-bdev-migrate. So we're going to run this now. Wow. And pretty quick, right? So that'll vary a little bit if you have a lot of stuff in your DB. But again, you're migrating, if anything, like up to a couple gigs off a spinning device onto the slower or onto the faster SSDs. So that command can take a bit if you've got a bunch of extra data. But at the end of the day, if it does take a longer period of time, that's just one disk that's out of the system, and we told it not to move data around. So we'll be safe there. Because like you can see on my system, it was instant. And of course, as things get a little more full, they're not as instant. So the next step here is, this was the part that kind of put my brain through a crunch when we went through this whole process as a team together. We had the new block device there and everything was good, but if I run ceph volume LVM list, I'll scroll up and look for number 1. It still only says it's just a block device. So what the heck? I thought we added it and thought we migrated it. Maybe I have to start the OSD? But no, that's not it. Ceph volume list, LVM list, actually reads the tags on the logical volumes themselves. So if I show you an LVS-O LV tags of, let's take a block device. This isn't the one but it's just for illustrative purposes. Sorry, copy, paste. It's underscore. Sorry, guys. So you get all this information here. Great. What if I do this right now on my existing LV that I created? Or sorry, I should be clear, on the existing SSD journal logical volume. Dev, ceph, db, nothing. That's supposed to be an O, not a 0. Sorry, I'm going fast now. There's no LV tags there. That's why ceph volume doesn't show up. And actually what would happen, even if we got this thing started, if we rebooted or whatever, it wouldn't start the OSD because those tags aren't there. That's how it knows who belongs to who, if you will. So with that all out of the way, how the heck do you get the tags on there? So let me make sure I've got this script here. Good, here it is. So what we're going to do is run add tags to the existing block device. Sorry, let me do this. Ceph volume LVM list. Because this is a horribly long process to do by hand, so we scripted it. We're going to take the existing block device of the OSD we're adding the journal to, and the device that we are going to the SSD device that we're adding to that OSD. And what the script does is essentially just, it adds 2 tags to the existing block device so it knows that its DB is now this, and then it takes a complete copy of the tags on that first existing block device, copies it over to the second one because they're actually identical, except one of them where we say one's type block and one's type DB. Anyway, the whole point of this, yes, and in classic demo fashion, the system I used here had the older version of the script on it, so let's try this again. And there we go. Those are a bunch of positive results that I expected to see. I swear you call me a lying Sebastian, man. I do these things on purpose. So let's, I don't want to, I can type this out. So I want to show you the result of our changes here. Dev, ceph, db0, and then so here's our new device. Remember, this had 0 tags on it, and now it's got all our tags. So what does that really mean, though? That means I can go ceph LVM list, and there it is. OSD1 now has a block, and it has a DB. We've migrated the data. It's aware. LVM's aware of the changes. So let's get the thing started again. So what we're going to do is we're going to unmount where that OSD is right now. Because I don't want to just start it again. I want to use ceph volume to activate them. I'm just going to do all. It'll just skip the ones that are already activated. Ooh, I should probably spell that right. And then what I like about this is it's kind of like, this will also guarantee that if this process works, reboot your OSD will start as well too. So let's activate them. So there we go. So as you can see, it started with 1. Those are all very positive results as it started, and then all the other ones got skipped. So let's take a look at our Ceph-S. And here we go, we've got 15 disks again. So it's back up. Volume, LVM list. We've got our block and our DB. Now I'm typing fast because I'm getting excited. We should OSD unset our no out flag. And the cluster's ready to go. Remember, we have our warning because we only set size to 1, but it sees a bunch of clean and active placement groups, which mean we didn't actually touch any of the data underneath. So, that's it. Okay, so that's a wrap on that process. Of course, you would rinse and repeat and do the other OSDs, but that's how you take a pure spinning OSD, create a new block DB on a new SSD, migrate it over, and start everything up without any downtime or without any data loss or anything like that, or any worries of migrating data around. Minimize your writes out to other disks and stuff. So I hope you guys enjoyed that. I hope you learned something, and stay tuned for more.